Okay, does anybody have any questions with last night's homework?
Yes.
Oh, come on. What?
Question 22 and 23.
22. Okay, so the first thing I want to look at is, I'm just saying, the first thing comes to mind is 2 and y. Now, some of you are going to make some mistakes here because you think that you have to be right the first time you set it up. So if I'm looking at that right off the bat, I'm just saying that's a short leg and a what? Hypotenuse. So I'm just going to show you 2 over y, short leg and a hypotenuse, y over z. That doesn't help, correct? 3 over this hypotenuse, that doesn't help. So I can't use that. Does everybody agree? So now I'm going to say 3 over x. I just randomly am picking 3 over x. 3 is the short leg and x is the what? Long leg. Short leg. Long leg. I don't understand what's the problem. 2x equals 9. X equals 9 halves. So right here, x now is equal to 9 over 2. So you might want to come down here and say x is just 9 over 2. Everybody with me? Now, if I were looking at this, now I can see this 2 and this 9 over 2 is z. Z is 13 over 2. Anybody got a problem with that? Anybody got a problem with that? Now, y to me, I'm just looking at that, staring, going, how did you not see that was the square root of 13?
No.
A squared plus b squared equals c squared. Right? Everybody good with that? Now, hopefully you understand what I'm saying is you set it up, you just set it up and you're wrong. So you just can't say, well, I can't do it. I tried it one way. All right, that's the relationship. Short leg, long leg, hypotenuse, a squared plus b squared equals c squared. Come on, guys, you got to admit that really is not that hard. It's really not. All right. So now let's take a look because he had so much trouble with 23. I'm looking at y and 10, y over 10, short leg to hypotenuse. Well, I see a 10 and I see a 20. 20y equals 100, y equals 5. So right off the bat, I now know that y is 5. And now I can understand why you're having so much trouble, right? If y is 5, then x is obviously what? 15. Now I have z over 15. Z is a long leg. No, z is the hypotenuse. No, I don't think so. Z is the hypotenuse. X is the long leg. Please look at that. Make sure you see it. I'm using this triangle right here.
Yeah.
You see what I'm saying, right? And it's, again, it's okay. All right. You have to practice. It's not the easiest thing to see at first. And then you start recognizing there's a small triangle, middle triangle, and a large triangle. So I have hypotenuse and long leg. So what's the hypotenuse and what's the long leg? 20 over z. Z squared equals 300. So z is 10 radical 3. How's that? That's not bad.
So when you have 300, what's like an easy way to like figure out what you have? Because I got 300, but I got 2 radical 75.
Well, 75 has a perfect squaring.
What is it? 145.
Or you could say 300.
Mm-hmm.
100 is a perfect square. 3 times 100. All right. Anytime you're doing the hundreds, that's a good one. All right. Somebody else, guys. Come on. Yes, Sophia, good for you. Let's look at 29. Let's see why that word problem was tricky. So I'm trying to figure out what X is, correct? So I'm looking at X right off the bat and saying X over 235. That looks like a long leg and a short leg. Do we agree? But I don't see on the big triangle, I have nothing. And that's not going to work. Do we agree? Right now, I'm trying to make sure I have 180 is this guy right here, right? Is that correct? Oh, I'm sorry. That would help if you read, correct? All right, so let me make sure. A bridge connects to a tunnel as shown in the figure. The bridge is 150 or 180 feet above the ground. At a distance of 235 feet along the bridge out of the tunnel, the angle to the base of the summit of the cliff is a right angle. So I'm sure this is a right angle right here. So this is my right angle. So again, everything is similar. Now, I see the tricky part. If this is 180, does everybody agree this right here is 180 also? That was why it was hard. So everybody see this vertical distance here is the same as the vertical distance here is the same as the vertical distance here. Does that make better sense now? So now I see these numbers, 235 and 180. Do we agree with that? So I'm going 180 over 235. That's a short leg and a long leg, correct? So now I have 235 over X. Is that helpful, Sophia? Do you see it now? Yeah, that was tricky. All right. So now I need help with 235 times 235 divided by 180. How much was it? Yes, sure he did. 307 is X. Do we agree with that? Was that exact? So X is 307. So then the height we can just say is 307 plus 180. Do we agree with that? Yep. And then D, if you wanted to, we could do the Pythagorean theorem with X and 235. Do you agree with this? Or you can say hypotenuse over short leg. So we could say 235 over D. This is short leg. This is hypotenuse. Short leg would be yeah, I don't want to, we don't have a short leg and another hypotenuse. So we'll just do A squared plus B squared equals C squared with 235 X and D. Is everybody okay with that? Is that helpful now? Yes, ma'am. What's the difference? How high is the cliff from the base? I think that's X, isn't it? Oh, wait a minute. What is the height of? So the height of the cliff is this right here, whole thing, it looks like. You with me? I think that's what they're looking for. But again, you understand, I don't care if you don't understand those words, right? I care if you can just find what X is, find out what H is, find out what D is. You with me on this? All right. But what is the height of the cliff? I think the height of the cliff is, yeah, that's a really, the summit is the highest place. So I'm assuming this H is the height of the summit. The height of the cliff, I think, would be X. But if you got that backwards, I don't really care. All right, the point was just to answer the missing pieces. You good?
We do 24.
All right, let's check out 24. An airport, a factory, and a shopping center, the vertices of a right triangle. So let's just draw a right triangle. Now, again, to me, drawing the right triangle, so it's not a square, the diagonal, right? You see what I mean? In other words, the legs have to be bigger and smaller. All right. So an airport, a factory, and a shopping center, the vertices of a right triangle by 3 highways. The airport and the factory are 6, the distance 3.6 and 4.8. A service road will be constructed from the shopping center to the highway that connects the airport and the factory. What is the shortest possible length of the service road? Well, which one is the right angle? An airport, a factory are the vertices of right, the airport and the factory. Oh, yeah, because the largest one, that was good. So the airport and the factory is 6. And then the airport, the factory, and the shopping center. Now, again, that was good, guys. The shopping center has to be the right angle because that's opposite the largest side. Is everybody good with that? And then we can just say the airport and factory are 6 miles. The distance from the shopping center are 3 all right, I gotta make sure I put the 3.6 properly. The airport and the factory are 6 miles apart. Their distances from the shopping center are 3.6 and 4.8. So which one did they list first? The airport. So this is good. 3.6 and this is 4.8. Do we agree? It says respectively. Do you know what that means?
And you can just look at the triangle.
But the respectively just means in that order.
Okay.
All right. A service road will be constructed from the shopping center to the highway that connects the airport and the factory. So essentially what they're saying, the shortest distance is a what? Is a perpendicular. Do we agree? So that's going to be the shortest distance from here to here. And that's X. Do we agree? Right? So this is the short leg, this is the long leg, and the hypotenuse. So essentially I'm looking for X over 3.6. Do we agree? Which is the long leg over the hypotenuse, the long leg over the hypotenuse. Do you agree with that?
Yeah.
All right, cross multiply, figure that out. All right, anybody else? Anybody? Go.
Please see 25.
Let's look at 25 real quick. Rhonda has a rectangle LW. She would like to replace it with a square that has the same area. What is the side length of the square? Someone tell me that. Easy, right? What's the area of the rectangle?
L by W.
LW. Area of the rectangle is LW. Do we agree? What's the area of the square? Same as the rectangle. So the square has what? LW, correct? So what's the side length of the square? Square root of LW. All right, square root of LW. What if the area of the rectangle was 25, what would be the area of the square? Or what would be the side length of the square? Right, because you just took the square root of the area. Right? All right, I don't know why that wasn't there, honestly, but that's good enough. All right, so now I got to pause this real quick while I collect that, and we have a nice little lesson today. So here we go. All right, I really would prefer that you just listen. All right, if you want to write things down, you can write things down, but I would prefer for some of you guys, it's easier. I'm not going to ask you to do these little proofs of how they discovered and based a lot of your trigonometry or your pre-calculus on this information. All right, and I'm always amazed at when I speak to kids who are in that class and I ask them about it, they have no idea. All right, so I want you to have an idea. All right, so first thing is we're going to talk about the formulas for a 45, 45, 90. Now 45 is just referencing the angles. So what I'm going to do is I'm going to draw, and this is how they kind of figured it out. I'm going to try to draw a square All right, and when I draw a square and I use the diagonal, I create two triangles, we agree? And what's gonna happen is this right here is going to be a 45-degree angle, and that has to be a 45-degree angle. Does everybody agree? All right, now watch. The side of the square I'm just going to call is X. All right, so this is X. What would this side down here be called? X. All right, now this is the hypotenuse. We'll just call that C. So what's the relationship between X and C? Very good. X, you're amazing. X squared plus X squared equals C squared. Look how easy that is. So now we have 2X squared is equal to what? C squared. So I take the square root, take the square root. The hypotenuse is always the square root of 2 times the side length of the square. All right, now I just don't think that's that hard. I don't need to memorize that. It was so easy for me to come up with that formula. So what does that mean? That means this is X radical 2. That means there's a relationship between all three of these numbers. All right, now to help you, all right, there's a 45, 45, 90. How many different angle measures are there? 2. So that reminded me that it must be a square root of 2 involved. All right. This is the leg. Do we agree? The hypotenuse is always bigger, correct? So if I say the leg is 7, what's the other leg? And what's the hypotenuse? 7 radical 2. Thank you for listening. That's how simple it is. Now understand the leg is smaller than the hypotenuse, correct? So that's how I knew. I had to multiply to get bigger. All right, so I remembered the leg times radical 2 is the hypotenuse. If I have the hypotenuse, how do I get to the leg? All right, let me say that again. From the leg to the hypotenuse, what do I do? Multiply by radical 2. So if I have the hypotenuse and I get to the leg, I have to what? Divide by radical 2. That's how hard this is. All right, come on now, that's got to make sense to you. If I have the hypotenuse, I'm going to a shorter side, correct? So to get to a shorter side, I'm going to have to do what? Divide. If I'm at the leg, I got to get to the hypotenuse. So I got to get to a higher or bigger number, right? So I have to what? That's all there is to it. So now I'm going to look down here at number 1. What is X? That's embarrassingly easy. All right, and like I said, for whatever reason, people find that hard. Number 2, what is X? 3. Wow, pretty impressive. See how smart we are? Number 3, what's that? 4 radical 2. We are great. Number 4. Now this is the one that's hard, so come on. We're not using our calculator. What do we do to get from the hypotenuse to the leg? Divide by radical 2. So your brain says, what is 18 divided by radical 2? Now you're coming up on your placement test. You're going to have to know how to do radicals. So we have to rationalize the denominator. So that means I have to multiply the top and bottom by square root of 2. And when I do that, I get 18 radical 2 over what? 2. And then 18 and 2 can reduce to what? 9 radical 2. That's all there is to it. All right, now stay in your head. If I have a leg to get to the hypotenuse, I'm going bigger, so I have to do what? Multiply. If I'm at a hypotenuse and I got to get to a leg, I need to what? Divide. There are 2 different angles, so I'm multiplying and dividing by radical 2. That's how simple that is. And like I said, I don't understand the difficulty. All right. It's always multiply by radical 2 or divide by radical 2. All right, so if I'm looking at number 5, that's just going to be what? Now, some of you are pretty slick. You know how to do that. You see the patterns pretty quick. 16 radical 2 over 2, 8 radical 2. You start to see the patterns and you can just see it's 8 radical 2. You don't have to do all that work if you know that. All right, some of you guys you know, haven't seen the patterns as well. You'd prefer to do the math. All right, so you just have to rationalize the denominator when it doesn't work out. All right, so now for number 6, what's the answer? Look, that is simple, simple. All right, now what we're gonna do is I'm gonna come back up here. Now I'm gonna describe for you the 30, 60, 90 triangle, which is not really harder if you pay attention. Right, I prefer, again, you don't have to memorize the formulas, but watch how cool this is. All right, so they discovered the 30, 60, 90 triangle based on the fact that if I'm trying to draw an equilateral triangle. So everybody's supposed to look at that and say, yeah, obviously that's an equilateral triangle. So all the angles measure how much? 60 degrees. Thank you very much. So this is 60, this is 60, and this up here is 60. However, I'm going to take and I'm going to draw the altitude, and the altitude gives me what degree down here? 90, which forces this angle here to be how much? That's exactly right. That's how they came up with the 30, 60, 90 rules. All right, now please look, because this is not a mystery. All right, I'm calling, does everybody agree? All sides of the triangle are equal, correct? So if this is X, this down here is what? X. So come on now. What is this length from here to here? 1/2 X, or we just say X over 2. Now, like I said, most people don't know that, but because we're smart and you're going to understand that the 30, 60, 90 triangle came from an equilateral triangle. If you forget all this, we just do that. All right. Now, the missing piece is the height, correct? So now I'm just going to do the Pythagorean theorem. All right. When I do the Pythagorean theorem, all right, I'm going to come over here and I'm going to show you that X over 2 squared plus H squared equals X squared. Does everybody agree with that? 1/2 X squared is the same as 1/4 X squared plus H squared equals X squared. Anybody got a problem with that? 1/2 squared is 1/4. Does everybody agree? Anybody?
How is 1/2 1/4?
What is 1/2 squared?
1/4.
1/4. Anybody have a problem with that? 1/2 squared, 1/4. Now I'm solving this for the height. I'm missing the height. So now here's the hard part. Let's see if your brain is working this morning. H squared equals 3/4 X squared. Most people are like, what? What? How do I get that? There's fractions involved. Right? Come on, don't be lost. I'm solving for H squared, right? So I subtracted 1/4, correct? And some of you are still asking me, what's 1 minus 1/4? What's 1 minus 1/4? That's how I got the 3/4. This is 1x squared. I'm subtracting 1/4 x squared. I'm left with 3/4 x squared. I take the square root now. H is equal to, do I know what the square root of 3 is? Well, no. What's the square root of 4?
2.
What's the square root of x squared? X. There you have it. So the height is always square root of 3 over 2x. That's the relationship. All right. Now, what exactly does that mean? That means that if they give me any part of the 30, 60, 90 triangle, I can find the other two sides quickly. So now I'm going to show you what I mean by quickly. So I'm going to draw me, you don't have to, just pay attention. I'm going to draw me the left side of that right triangle. All right, come on now, please pay attention because I'm going to do this about 10 times and you're just going to zip right all the answers. If this is 10, what's this guy? What's this guy? 5 radical 3. That's how easy. All right, so this is the 30 degree, this is the 60. Now listen to me. I remembered it by saying 30 is half of 60. Opposite the 30 is always half the hypotenuse. Right? Now there's 3 different angles, a 30, a 60, and 90. Do we agree? So that means there's a square root of 3 involved. Just like before, the 45, 45, 90, there were two different angles, so I knew a what? Square root of 2 is involved. So in the 30, 60, 90, we need a square root of 3. All right, so now from the short leg to the long leg, all I do is multiply by radical 3. Everybody with me? All right, now put your pencils down and just look up here on the board. I'm going to try to trick you now. All right, let's see if you can remember the patterns. So now what I'm going to do is I'm going to say this is 8. What's the hypotenuse? What's the biggest leg? All right, now I'm pretty happy with you on that. So I'm trying to get wild and crazy. So here we go. Let's have some more fun. Let's say this is 7 radical 3. What's the short leg? What's the hypotenuse? Come on now. It's not that difficult. There's a pattern. All right, that's a pattern. All right, now let's get really crazy. Let's call this 5. What's the short leg? 2.5. The long leg. Now, of course, in math, we don't say 2.5. We would just say 5 over 2 and 5 radical 3 over 2. But do I really care? No, just on every advanced math book, we don't use decimals. All right. So now let's try to get a little tougher. So let's say I said this was, and again, this is where it's helpful getting ready for your entrance test. Let's say I said this was 2 radical 3 to try to throw you off. What's the hypotenuse? What is it? 4 radical 3. You're just multiplying it by 2, right? Now remember, radicals times radicals. You can multiply radicals, but you can't multiply a radical and a number. Does everybody understand what I'm saying? 2 is a number, 3 is a radical. All right, so now what's the long leg? Thank you, 6. No, come on, come on. Your first thing out of your mouth shouldn't be what? It should be, wow, he's just multiplying by radical 3. So what is 2 radical 3 times radical 3? Definitely not 2. All right, 2 radical 3 times radical 3. What's radical 3 times radical 3? 3 times 2. You're welcome. Here we go. Let's get a little more crazy. Let's see if I can do something. All right, let's call this 10 radical 3. What's the short leg? What's the long leg? 15. That's it. All right, now let's just make it as hard as I possibly can. All right, let's do this. Let's say this was radical 7. The short leg would be what? Radical 7 over 2. I just took half of it. Now what's the long leg? Radical 21 over 2. Because radical 3 times radical 7 is radical 21. So everybody with me on that? This is a good review of your radicals now. You should be paying attention. All right. So let's come over here and say this is, this I'm going to say is 9. Now, I notice I've never gone from the long leg to the hypotenuse. Right, I always go long leg to short leg to hypotenuse, or hypotenuse to short leg to long leg. All right. So now from 9 to the shorter leg, all right, am I getting bigger or smaller? So if I'm getting smaller, do I multiply or do I divide? So I'm dividing by what? Come on, guys, you divide by radical 3. 9 divided by radical 3. If I rationalize that quickly, that becomes 9 radical 3 over 3, which is the same as 3 radical 3, right? And then the hypotenuse is what? It's just a pattern. It's all it is a pattern. All right, now I learned this, all right? So I don't, if I forget the pattern, I can always do what? Recreate it. That's correct. I can figure it out. I don't have any of that memorized. All right, I can figure it all out. Same thing with the 45, 45, 90. To me, that's pointless information because I can figure it out. I don't have to memorize it. All right, there's some things you have to memorize. These are not part of it. All right, now let's have some more fun. Let's drop down to here, my 30, 60, 90, number 10. All right, let's see if I did a good job now. Now it's a little bit more difficult because the triangles are a little switched up on you. All right, so don't let that confuse you. All right, the 30 is 1/2. If the 30 is 1/2, what's the hypotenuse?
2 or 1.
1, thank you. What's the long leg? 1/2 radical 3. You said that correctly, but listen to me. The reason I'm correcting you on this is because I know in a couple years you're not going to write it like that. You're going to write it as the square root of 3 over 2. All right, but 1/2 radical 3 is perfectly fine. It's better to say radical 3 over 2. Let's look at 11 now. All right, identify that's the short leg. So what's the hypotenuse? And what's the x? Yep. Come on now, don't sit there and don't write down my answers. All right, don't listen to other people tell you what the answer is. You know the answer. If you said something wrong, correct it. All right, 12. All right, 11, what is x? We're going to say 11 over 2. And what's y? 11 radical 3 over 2. Now, I know some of you are getting more familiar with the fractions now and how I want you to write the fractions, but that's fine. If you said 5.5 and 5.5 radical 3, I wouldn't even care. All right, but that's just not how they're going to be writing it when you go to high school. All right, 13. Here we go. Now, you have to identify what that is. To me, immediately, I just come up here and say 60. So this is the what? 60, correct? Now I'm going to get smaller, so I have to do what? Divide by radical 3, so I'm left with 9, and then y is what? Now, if you thought it was like 9 radical 3, if you didn't know it was 9, it would be helpful if you said, hey, slow down some. Let me get it straight. Fix it now. Anybody have a problem with that? Does everybody agree? It's like simple. Simple, simple. All right, here we go. Let's knock out 14. Uh-oh, this one could be challenging for some. X is, I know, but we're going to do it the long way. What do I have to do? Divide by radical 3. Divide by radical 3. Now everybody's rationalizing. So that's going to be 12 radical 3 over 3, which is the same as 4 radical 3. And then y is what? 8 radical 3. All right, now don't be confused by an equilateral triangle, correct? Because I demonstrated the equilateral triangle, right? So what's the altitude? So here we go. Watch how nice this is. We're going to draw, we're going to draw an equilateral triangle. Try to. All right, and each side is what? 36, 36. So if I draw the altitude, come on, this should be that quick. What's this distance from here to here? 1/2 of 36, and someone knew that was what? So the altitude is what? That's how easy. 18 radical 3 is the altitude. Everybody good on that? All right, if you forget, you can just write it out. That's a 60, that's a 30, that's a 90. Now, if the altitude is 45, all right, so we can draw it again. The altitude is 45. Then what's the short leg going to be? Thank you. 45 divided by radical 3. So we rationalize, which is the same as 15 radical 3. So then the side of the triangle is what? 30 radical 3. Come on now. Listen, some of you guys I just worry about because you're leaving in a while and you're still not asking me any questions. All right, anybody have any concerns with that? Right, I just drew it out for you, laid it out. Hopefully you're saying, wow, that's pretty easy. I mean, it's going to take me a little time to, you know, practice a little bit, but it's not hard. Go. This is 15 radical, this was 15 radical 3. Do you agree? This is double that. 30 radical 3. Or watch, you could even say, okay, if this is 15 radical 3, then this right here must be 15 radical 3. So the whole thing is what? 30 radical 3. I'm trying to show you a whole bunch of different ways of looking at it. Right? You with me on that, right? No, we're good. We're good. All right. And now there's just lots of practice. And the practice, I mean, there seems to be a lot of problems here, but you know, I'm looking over here going, if that's 52 radical 3, this is 26 radical 3. And this is just 26 times 3, 78. That's how fast it can be done. Right? All right. Now, there's fun little word problems down here. These are the ones that are kind of important. So I really would like for you to take a look at these. All right. All right, especially this one right here. This 37 is a nice little cool little problem. 36, the hexagon is an amazing shape. All right. So practice, practice, practice. All right. Good work for today, guys. I'm pretty happy with that. We got a whole 3 minutes. Come on. Don't think there's a lot of work here because it's just, you know, putting down the numbers quick as you can. The word problems, yeah, are a little bit trickier. Yes.
Resolution